In this video we're going to find the equation of a line. Now, to find the equation of a line when given any 2 points, you need to first find the gradient, and then you can do one of two things. You can substitute a point to find the y-intercept, which could be b or c, in either y equals mx plus b, or if you're using c, y equals mx plus c. So that's one way. Or we can use y minus y1 equals m outside of x minus x1, which is a very handy formula that you can use when given 2 points. So you will see reasons why you'd want to use the first one and also the second one given different situations. But first, we need to be able to just find the gradient of a line joining 2 points. So to determine the gradient of the line joining the pair of points minus 3, 8 and 5 and minus 2, we normally we'd have to graph this, but there's a way we can get around it. So we know that the gradient is rise over run. And something that I like to use is the idea that y's are over the run. And what that means in this situation, it is a bit of an odd thing to say, is we've got these 2 points. We'll call this point 1, point 2, doesn't matter which one was which, I've just picked those. We've got, this is going to be x1, this is y1, and this is x2 and y2. And when we have identified that, we can use them in this formula here, and that is y2 minus y1 over x2 minus x1. And the way this works is, in this situation, we get the y2, in this case it's minus 2, and we subtract it from our y1, which is 8. We do the same thing for the x's. So we're going to have our x2, which is 5. We're going to subtract it from x1, which is negative 3. So when we take away a negative, we're going to be adding it. Okay, so we've got minus 2 minus 8, that's going to be minus 10. Over 5 plus 3, that's 8. And then we can simplify this, or just divide the top and bottom by 2. We're going to have minus 5 over 4, and that's as simple as we're going to get. So for these 2 points, the gradient of the line is, at the very least, we know that it's going to be minus 5 over 4, and that's using this formula here. It's quite important. I'm just going to write it. We're going to be using that throughout, so we're going to be writing it again every single time we need it. Here, for the next example, it says finding the equation of a line when given the y-intercept and a point. So the question actually asks, find the equation of the straight line shown. So we've got this line here, and there is a point on the y-axis, which means that's the y-intercept, and that is when y is when x is 0, y is 1. Okay. So as we've got that, we're going to use that information to actually input it into an equation. So the equation we would have is y equals mx plus b, and we know that the b value is going to be 1. So we know at the very least that y is equal to mx plus 1. Now to find the m, we're going to use that same formula. M is equal to y2 minus y1 over x2 minus x1. Now you'll notice with this formula that we're labeling them y2 and y1, x2, x1, but it's not squared. It's not up here. It's below it. This is called a subscript. So a subscript is just kind of a way we label things. So given this, we'll make this our first point. So I'm going to rewrite these. We're going to have the first point is 0, 1. That's x1, y1. And the second point is 4, 13. So it's going to be x2, y2. So now we have these. I'm going to put them into this formula. So the gradient is equal to 13 minus 1 over 4 minus 0. So 13 minus 1, that's 12. Over 4 minus 0, that's 4. And then we can simplify this. Both the top and the bottom are divisible by 4. So 12 divided by 4 will give us 3. And 4 divided by 4 gives us 1. So our final answer there will just be the gradient of 3. So as we know, our m is 3. When we put it back into our equation, we're going to have y is equal to 3x plus 1. So that's when we're substituting a point to find the y equals mx plus b. So we've got our y-intercept and we can find just the gradient there. Okay, the final example is when we're finding the equation of line when given 2 points. So there's two ways of doing this. So the first method is to get it in the form y equals mx plus b or c. And the way we do this, first of all, we need to find the gradient of this. So we're going to have m is equal to y2 minus y1 over x2 minus x1. I'll identify these points. We're going to have as our first point 3, 11, x1, y1, and the second point is 6, 7. So that's x2 and y2. So when we put them into this formula, our gradient will be 7 minus 11 over 6 minus 3, which will equal negative 4 over 3. So that's our gradient. Now to find the b value, we need to rewrite this formula with the gradient now in there. We're going to have y is equal to negative 4 on 3 x plus b. And we can pick either point and substitute it in. So I'm just going to pick this one. It wouldn't matter which one you do. So if we substitute this point, we're going to have 7 is equal to minus 4 on 3. And the x is going to be 6, so times 6 plus b. So if you type that in the calculator, we'll just do that now. We'll have minus 4 on 3, and that's times 6. You can do times or in brackets. We get negative 8. So 7 is equal to negative 8 plus b. Now to get b by itself, we need to add 8 to both sides. So if we add 8 to both sides, we're going to get 7 plus 8 is 15 is equal to b. So now we know what our b is, we can put it back into this. So I'm going to put it right back in there. And we're going to have y is equal to minus 4 on 3 x plus 15. And that's the equation of the straight line that's shown there. Now the second method, it still involves the gradient, so we don't need to redo it. We already know that the gradient, m, is equal to minus 4 on 3. But this method is using the formula that we mentioned in the second idea, where we have y minus y1 is equal to m outside of x minus x1. Okay, so really the x and y points can be either. In this case, we'll use our 1 point here, just to keep it consistent. We already know our gradient because we've used this formula. That's the formula we'll use to find the gradient. So we have y minus y1 is equal to minus 4 on 3 outside of x minus x1. And now we'll sub in that point. So when we substitute in 3, 11, we'll have y minus 11 is equal to minus 4 on 3 outside of x minus 3. Now, when I was first doing this, I wondered why we were only substituting in one value, and that's because at the end of it, we want it to look something like this, where there's x's and y's. So we'll leave those x's in there and the y's in there. But we need to rearrange just to make it a bit neater. So the first thing we're going to do is we're going to expand these brackets. So if we do this expansion, we're going to have y minus 11 is equal to minus 4 on 3 x plus 4 on 3 times negative 3. Well, that's going to be positive 4, because those 3's cancel each other out in this situation. And then we can rearrange this a bit. So I'm going to add 11 to both sides. So we'll have y is equal to minus 4 on 3x plus 4 plus 11 is going to be 15. And that's our final answer. And you'll see that they're the same. So you can use both methods to identify that you're indeed correct, or you can just pick one of these methods and use it. I personally prefer this second method because we just input things into a formula, but this method works just as well.